All right, so example 3 is very similar to the last two that we were doing, but um, the equations are just a little more complicated. They're just a little more, they don't look like they're in either one of the forms that we had initially there, that the q equals a b to the t, or the q equals a e to the kt. Okay, they don't look like they're quite in either one of those forms. But that's okay, we can still deal with it. Let's use the properties of exponents and rewrite these so that they are in one of the forms that we are familiar with. So what I can do here on this first one, now I've got this 70, but what I'm going to do is just break this up. I can rewrite this as e to the, I got this t minus 2 over 5. So I'm going to write it as t over 5 minus 2 over 5. Okay, I'm just going to distribute that 1/5 essentially. And so now I have the difference. I have an exponent that's a difference. Okay, so I can actually break that into two different exponents, or two different, I can take, well, I'm going to write it as e to the minus 2/5 times e to the t over 5. Okay, because I know that I can really treat this as plus a negative 2/5. And then I can use the product, write it as a product. All right, so now this is starting to look a little more like what we want. This whole thing is a constant, so let's put that in the calculator and see what we get. If I take 70 times e to the minus 2/5, I end up with 49.9224. Okay, and then 1/5 is 0.2, so I'm going to write this as e to the 0.2t. And now it's in the form e to the kt, right? So I have a e to the kt. And now I can figure out what they're asking for, which was a, r, and k. So a, I can just read right off of that, is 49.9224. My r value is going to be what? It's going to be, all right, so okay, I've got it in e to the kt form. I can also write this as, let me just go ahead and squeeze this in, 49224. Now if I just take e to the 0.2, I'll get 1.2214 to the t. Okay, so now I have it in the form a b to the t, where my b is 1.2214. And so that means that the growth factor is 1.2214, which makes the growth rate r equal to 1.2214 minus 1. And so the r value is 0.2214. Okay? And then finally we're asked for the k, which we can get from our equation, and we get k is 0.2. All right. So we just had to do a little rewrite on that equation in order to put it in a form that we're familiar with. So take a look at the next one. It's very similar. We can use similar techniques. Take a look at it, give it a try, pause the video, and then come back when you're ready. All right, so we're going to rewrite this one as well. So I'm going to rewrite this as 2. Now I've got this whole quantity, 1 minus 2t, all divided by 3. So I can rewrite this as 1/3 minus 2t over 3. And then I can write it as a product, right? So I can write this as 2 to the 1/3 times 2 to the minus 2t over 3. All right, so now let's we can calculate this constant right here. This 2 to the 1/3 is just 1.22. No, wait, 1.255559 when I put that in my calculator. And then let's see, I can rewrite this. Let me just rewrite this as this part right here. I can write it as 2 to the minus 2/3 L to the t. Okay, so when I do that, then I can calculate 2 to the minus 2/3, and I'll get 0.62996 to the t. Okay, so now that's in the form a b to the t. Now let's also, just because I know we're going to be asked for k, let's also put that in e to the kt form. So the a value will be the same, 2559, but now I want this to be e to the natural log of 0.62996, and all of that to the t. Okay, and then that'll give me this natural log will give me the k value. So let me rewrite it one more time. 559 e to the, okay, so when I put the natural log of 0.62996 in, I get minus 0.4621 t. Okay, so now I also have it in a e to the kt form. All right, so a is equal to 1.2559. R is going to be essentially this 0.62996 minus 1. Okay, I didn't break that up into 1 minus something, but I can do that now. I get minus 0.37004. And of course, my k value, I can read off from the last equation. It's minus 0.4621. All right. So I will meet you in the next video.